In this video, I'm going to discuss a methodology for using data repositories that can be used as used projects in a Cameo system model, specifically when we're working with parametric models, parametric diagrams and analysis models. And in this case, we're talking about integrating a payload with a launch vehicle and using the system interface spec and launch vehicle data as libraries. This is sort of a layout, high-level layout of the structure that we're dealing with here. So we're calling this the Mission Integration Enterprise, and it's an aggregate of a number of components, one of which is the payload contractor, who's supplying data for the various early integration study analysis workflows to the system engineer and integrator. And we're proposing using the Teamwork Cloud environment, which would include the actual workflow model. In this case, we're going to do the acoustic workflow. And we're also building libraries for each launch vehicle. Since we know that the contract for the Air Force has been awarded to ULA and SpaceX, we know what their stable of vehicles is, so we can build libraries to house the integration information or data that we want from those launch vehicles. And then we've captured the system interface spec, the SYS, as a library, specifically in this case for the acoustics. This is an internal block diagram showing the flow of data into the acoustic workflow model. So it's going to be drawing on the SYS library, and it's also going to be drawing on the Falcon 9 launch vehicle library. That's all within the Teamwork Cloud environment, and then the payload contractor is going to be uploading data into that environment via an Excel interface. The SYS library model looks like this. It's managed on a Teamwork Cloud server, and so it's online, and it could be part of the actual requirement set. In fact, in this case, we do have the SYS brought in as a requirement model. We also have the system performance requirements document as a requirement model, but it could be a separate model for each workflow. The structure is similar to what we would refer to in the Unified Architecture Framework, or UAF, as a logical data model. Basically, a package is the LDM structure, and the data elements or blocks contain, in this case it's SysML, so it contains value properties. In UAF we would be using measurements, but they're basically analogous. And what you're looking at here is the representation of the SYS library in the model on the containment tree. So there's the SYS payload envelopes block with its value properties, and you'll notice that we're using instance data. So that's really the key to making this methodology work, as you'll see. And speaking of instances, this is the instance table that's associated with that SYS data model. So we have the standard frequency spectrum from 31.5 Hertz to 10,000, and then the associated sound pressure level values at each of those frequency levels in decibels for payload category A, B, and C. The launch vehicle library model is very similar. We have built, or would propose building, a separate Teamwork Cloud library model for each launch vehicle. So in this case we have one titled LV Data Model Test Falcon 9, and the packages and package structure for the data elements are similar. In this case we've got the SpaceX Falcon 9 configured as for a greater than 4,000 pound payload, and we have data blocks for the dynamic load factors, which we're not going to be using this time, the lateral and axial, and we have data blocks for the frequency sound pressure level frequency spectrums for the east range and for the west range. And this is what they look like. So here's the acoustics east, here's the acoustics west. They're slightly different profiles or different curves. Just for your information, we're not using it today, but here's the load factors one. These are the corner points for an envelope that defines the space for that launch vehicle where it's generating dynamic loads both in the lateral and the axial direction. The way that each of these libraries is used is that we bring it into the actual workflow model, the analysis model, through the process of using a project. So we go to projects or use server project, and then use that server project. So you can see that the Sys data model test acoustics is at version number 5. The Falcon 9 model is at version number 4. And but each of these is sitting in as a used project for that analysis model. So how do we use these libraries? So the first thing to do is build an instance table. And as I said earlier, all of this is based on the flow of instance data from the libraries and from external sources into our analysis model. So we build a master instance table for the analysis model, and we have to classify it in this window here using several blocks. The first, at 3.8 acoustics, that's just the paragraph number for the Sys. That's the basic analysis block that we need to build our parametric model. We also have overall sound pressure level analysis block. As you'll see later on, we have to do this to do that secondary construction of the OASPLs. And then these two, the Sys SPL envelopes and the Acoustics East F9 GT4K, those are coming from the library. So we draw those from the used projects, drag them onto our classifier, and so what that gives us is these columns in our instance table. And the first 4 of these columns are going to be populated with data from the Sys library. The SPL payload data is going to be brought in externally via an Excel file that's synced to this model via the export Excel function. This column, this is the sound pressure level data for the launch vehicle that we're looking at. This is going to be populated with instance data from the launch vehicle library. Here is the attached file. So this PL template.xlsx is an Excel file that has standardized inputs that's provided by the payloader into the integration process. That's attached to the Cameo model. And you can see here in the lower left, the way we link it or synchronize it to our model is the Excel file has 2 columns, the 1/3 octave band center frequency spectrum, and then the SPLs associated with each of those. And so we have a linkage to just the SPL for the payload in the instance table, as well as the frequency. So over here on the right, you can actually see what those 2 columns look like. After we synchronize the data and bring it into our instance table for our workflow model, this is what it looks like. We brought in 26 instances. We've populated only 2 columns, the frequency and the SPL for the payload. What we've also done is generated undefined booleans here, which are going to be calculated once we actually run Cameo Simulation Toolkit. The differences will also be calculated as well. So the next step is to open the read-only instance table from the launch vehicle library. And I say it's read-only. Unfortunately, this is the one item that can't be completely automated because we are actually going to have to go open up that instance table in our containment tree from the used project and do this step. We're going to have to highlight the sound pressure levels and copy them, and then paste them into the instance table for the analysis model. So that's what we do here. And then same thing with the Sys. In this case, it's a read-only. We only need to copy 3 columns because we already have the frequency spectrum data in the analysis table. So now this is our completed table before we run the analysis. We've got the frequency, we've got the SPL data for the Sys, we have the SPL data for the payload, we have the SPL data for the launch vehicle. There's only one last step, and that is that if we want to calculate the overall sound pressure levels, that's going to involve summing the transforms of the SPLs and then doing a log transform on those. So we do that by bringing all 26 instances into one 27th instance that we've created here using one of the part properties from our analysis block to give us a way to put those in. So we eventually hide those, but you'll see as we look at the parametric diagram how that's going to work. So speaking of parametric diagrams, there's two in this analysis model. This first one calculates the differences between the payload SPL profile and the sys and the launch vehicle profiles. And then it notes the exceedances. So these value properties are then the differences. Then that goes into this constraint block. If the differences are less than 0, meaning they're negative, then we're going to generate a true value for an exceedance at that frequency level. And so those are the 4 booleans. These inputs also feed into the transforms of each instance of SPL value. So that SPL transform, there's the expression for that. It's done for each of the 5 inputs, and then what comes out here are these value properties that are going to have to be summed in the next parametric diagram. One thing to note though, this little caret symbol here on these 4 value properties, what that indicates is that these are not coming from the containment tree in the model. They're coming from the used project. So these 3 are coming from the sys library. This one here, the SPL LV F9, is coming from the Falcon 9 library. And remember, the way we did that was, it's sometimes called a base classifier, but we used those the blocks that hold those value properties to classify our analysis model. So that means we can use them. We can actually drag them up and use them in our model. And so that's the methodology that we're proposing that we take for all of these, is to use libraries like this. And then the second parametric diagram that calculates the overall sound pressure levels takes these 5 transforms. And remember, there's 26 instances of these, so that's why we have to have a multiplicity on this going into this constraint of star, which means many. And this little calculation just adds them all up and gives us a new variable called sum, SPL transform, for each of those, the category C, B, A, and the payload as well as the launch vehicle. And then this final transformation expression turns those sums into the overall sound pressure levels, which then are put out as a separate value property. So here is what the instance table looks like after the analysis is run using Cameo Simulation Toolkit. So you can see that we have the differences populated. You can see some of those are negative. That's where there are exceedances. And the booleans now are checked true if there is an exceedance at that frequency level, that frequency spectrum level. So here's where the differences are calculated. If it's true, it's checked here. And then down here, in that 27th instance row, we have the overall sound pressure levels for the payload, the launch vehicle, and the category A, B, and C. What's nice about using this instance table as an interface for reading in data and running your analysis on it is you can also read it out. So we've also got another Excel file that's attached to this model that receives the output results. And so we can export that to Excel. So here you see all the exported values. Here are the differences. And you can see the differences are in red font with parentheses. And if there's an exceedance at that value, then it's also going to show the Boolean true here. The other thing that you can do, since this is Excel, you can put basically a bar chart here, and those values down there at the bottom are automatically read in from the instance table in Cameo. And once those values hit the Excel file, it's going to populate this chart and be the data behind it, so you can actually visually see the overall sound pressure levels.